recording. Okie dokie. I probably don't even need that. It's Discord. I don't need open. What's this? Why? You cannot minimize Zoom. Sure, whatever. Share screen. Share. Okay. Meeting controls are up here. The top. Okay, there we go. Do. Okay. Oh, this is not what I want. It's that later. Okay, how do I make this go up? Control Alt Shift H, really? Control Alt Shift H. That's such a long string of things to do. Lordy. I'll get to that later. Wait. So, doesn't appear that anyone has arrived yet. Right. Whoa, what did that do? Oh, version history. Okay, so we are going to be going over all the topics you need to know for exam 2. So first things first, I suppose I should probably note this here. First thing you actually need to know is everything from exam 1. Because programming is not going to stop using old stuff. That's unfortunately not how programming works. It's you're going to use all the stuff you used in lecture 1 through 10. So exam 2 is specifically over 11 through 19, but you will need to know everything from lecture 10 and previous. So, oh, you did we did nested loops twice. No, neat. Yeah, but so nested loops, while loops. We just don't use while loops, which is so sad. They're so much better. While loops, for loops, all that stuff. You're gonna use it. And if you don't, then you're gonna lose points. And you do need to know about it. It is very important. So this isn't gonna go over that. I'm probably gonna go over some of it anyway, just because I'm gonna be reviewing this stuff, and this stuff comes from here. But first things first, we're gonna be going over 11 to 19. And if anyone actually shows up and wants to ask questions, they can do that. Not currently here, that's okay. So functions. First of all, we're gonna go over functions. So what is a function? I'm gonna act like I guess I can just close this after it's saved, close. So I'm just gonna act like you didn't show up to any of the lectures because maybe some of you haven't, which is okay, I understand. It's probably not open. Well, so we're gonna program in here, and this is gonna be how I show stuff off. So first things first, we have functions, right? So what is a function? So a function is she used an analogy, which is pretty okay. I think it's a decent analogy. Where is it? Code is a recipe, yeah. So that's a pretty decent analogy. So instead of I don't know how another way of describing it without it being, I don't know how to break that analogy down into just smaller components, but yeah, basically you have whatever you have in your program. You're gonna have you have import something or other, probably math at random. You're gonna have inputs. You're gonna have let's say what's something bank teller statement, sure. Bank, it's gonna be someone's bank account, and you have your input, and then you'll have you're gonna do something with it. We're gonna look for it and find bank details, and we're gonna have like a dictionary with all the bank accounts in it. And after we do something, after we process the input, then this could also be a file, right? This could be a file. We could have file equals open, whatever. file stuff, and then we're going to do something with it, go over all of it, have a for loop here, something. And then finally, we're going to have an output. So we're going to print out something, or maybe we're going to write to a file. I'm pretty sure we learned how to do that, but I don't remember off the top of my head how to do it. But yeah, so I'm going to go over that. And what functions do with this, right, is that you could put this all here. And what you might have to do is that, for example, you might not want to have bank account, like asking for the bank account and finding bank details. You might not want to do this here because this might take up like 10 lines or something, right? Just in the middle of your program. When instead, what you could do is you could, well, we have to do main first. So main, I think this is how you do it. Here, let me open my, I don't remember off the top of my head exactly how to do main. I'm not a remembering everything sort of guy. I'm a do it and opening in VS Code. No, don't open in VS Code. Silly Python. For some reason, idle doesn't show up as a does not show up as a program to my computer. So my computer, whenever I want to open these, I have to go here and it doesn't remember it. So it's like really annoying. Yeah, so it's def main. Yeah. So go in here, we go to our program that we're writing really slowly. So we're gonna have def main, and then we're gonna have this, it's blank args, so no arguments. And then we're gonna tell the program that they're all in main by tabbing. These are all in main. So, but we have all this stuff, and we're probably gonna be doing this. We might be doing this a few times. We might be doing this a few times. Hello. If you want to ask questions, go ahead. I'm just going over content. So, if you don't want to go over this multiple times, maybe you have put all this in a while loop and you want it to do it multiple times. So someone you just keep asking questions to, you can keep looking for your bank account, whatever. So what you can do is go up here and we'll do def, fetch bank details, right? So instead of having this space taken up here, we can have this equal to fetch bank details. So, and then you put in the, bank account, someone's bank account information. And then whenever you want to fetch all those, you want to fetch a dictionary full of someone's bank account details, you can just call it. And, when we're doing these really small programs, it might seem, like, whatever, it's just a few lines of code, but this is really like teaching you good patterns, say hobbies, just I don't know how to say it, but it just teaches you the right thing to do. I'm not remembering the word, but this is the correct thing to do, is to put these things that you're going to use a lot of times and put them into these functions, so that instead of having to copy and paste it every time you need it, you could just call this function. And then you don't have to worry if you miss something. You have to worry if you miswrote a variable, because what's going to happen is all the information you send in here, bank, ID, whatever, it's going to just go into here, and then it's going to be rewritten. It's going to be poured into this variable. It's going to become this variable. And then when you're talking it to it, so you say, if bank ID in, bank underscore get bank dictionary. So you probably have to send that to it, or you could have a global variable. I'll mention that later, but we have bank underscore dict equals. I don't remember how to initialize it. What was it? I don't know. I remember how to initialize dictionary. Oh, right. It was like this, and then it was like, say, A, and then 1, I think. Yeah, I think that's how you do dictionaries. Yeah. So you can have bank dictionary, and then when you go in here, you can check, is my bank ID in this dictionary? And if it's not, then maybe this will return, like, maybe this will like return an error code or something. Or maybe instead it'll call on another function. So we have another function, right? So we'll have def, and we can have setup. So it's a new account, new underscore account. And then instead of this failing and just not working, or having to write, it's a new account in fetch bank details. That is not fetch bank. That's not what fetch bank details is doing. That's setting up a new account. So instead, if it's not in here, so it'd be not in, then you would call new account, and you would send them, the bank ID. And then here, maybe it would ask for more details. So you'd have, like previous bank, maybe have credit score, and you'd have to ask the person. So you have input, a string or whatever, and then you'd ask them here. You'd ask for all of this information. Then once you got all this information, then you go into bank dict, and you'd have bank underscore dict. Like I think it's .add if I remember correctly. Just go here real quick. Functions. I think it was 17 if I remember correctly. No, maybe 18. Yeah, we did dictionaries more recently. No, we didn't. Maybe it was 16 dictionaries. Yeah, so 21. So if we go here, we have dictionaries, and it's gonna have dictionary functions somewhere over here. Indexing. I'll get more on this later. I'm just explaining functions right now. This isn't like in the world if you don't keep up with this super well. So dot gets. How do I don't remember. Yeah, one of the things I don't like is that all these different data structures. So we're going to talk about all the data structures. We have list, we have nested, we have tuple sets and dictionaries. All these different data structures have different ways of adding and adding stuff in and taking things out and all this. I'm annoyed by it. I don't like that you use different things for every single thing, one of them. Not a fan. It looks like it solves this somewhere. Yeah. Well, whatever. .get .items. That's just some basic operators, it looks like. Mutable. Okay. Add. Okay, so you can add it like this. Okay, so it's just like that. That's what I was hoping it'd be, but I think it's set that has .add. It might be that. So, you want to add a new thing. So you have their bank ID. Oh, sure. You'd have bank ID going here. Bank underscore ID. And then we'd put in bank underscore ID, and we'd put in, I don't know what one would be. I guess we can just say 2. Yeah. And then, that's the thing about functions. So instead of all this clogging up here, instead of having this while loop or for loop with 50 lines, instead our while loop can have 10 lines. And then we can have these two do all the other stuff, and we only have to call on these functions. And that's like the really big thing of functions, is it lets you make your not only does it make it look better, but more importantly, it reads better. Like you could have a program that works really well, and you don't have a single function in it, and no one can read it. No one will have any idea what it does. But if you have all these functions in here, well, they're named, so you tell the reader what it does. This is a new account. This creates a new account. This fetches bank details. This is the main method. Call main over here. That's one of the big things with functions, is it tells people what you're actually doing. In main, you have the title of this. This would be bank account program, and then you have main. So that's what the bank account program is going to run in, right? And then it's just all this code. It's not telling people anything, especially if you don't have comments, which don't do that. But these they tell you what they're doing. So when you call fetch bank details, well, I know, oh, so this is gonna pull the bank details, and then I go over to fetch bank details, and I can see if they don't have a bank account with whatever bank this is, then they'll make a new account. This is very readable. I can look at it and I can tell you what it's doing. I can tell you what this program is doing just by reading these function names. But if I were to just write this all in here, and maybe I didn't comment very well, then it would not be readable. It wouldn't make sense. And it's not just for other people, it's for you. If you come back to this 2 years later, you're not going to know what the hell your code does. I don't know what my code does after like a month, right? So it's very important that you actually can come, and even not even like a month, maybe you're doing this in the middle of the night or something for whatever reason, and you come back tomorrow and you look at your code and you have I have no idea what it's doing because you have like 100 lines of code, really complicated. And you're just like you just can't work on it because you don't know what it even does. So this sort of modularization, making these functions, this can do a lot of work to make your code readable and clear. And modular, and you can mix and match. And maybe, if you're making a new program, you just copy this, you can plug it in over there, and you don't really have to swap any of these variables. Maybe a few of them, especially this like global variable. You have to swap that out. But other than that, all of it will be basically the same, and you just plug and play it, right? And you can't do that with your main. If you have code in your main method, you can't do that. You have to swap out all the variable names because they might be the same variable names as something in your new main method. So that's just a really like basic primer on functions and why you use them. Obviously, they have this up, or not this one, lecture 11. So she has lecture 11 all the way up. It's very long, 200. Oh my God. Yeah, but I mean, if you want to, I don't know actually if you can watch these Melto video. Can you watch them? I don't know. Let's see. Sign in because your browser is not accepting cookies. Oh my gosh. So I think she recorded the slides. Yeah, okay. So, or these are just reviews. Yeah, these are just reviews. I mean, yeah, but here we go. That's really old and not very useful. Yeah, whatever. So yeah, we have 11 to 2, 12, 13, 14, 15, 16. So, you can go and check out these, or you can go check out the files where they have all of them. It's kind of up to you what you do, but I'm just trying to make more sense. I'll go into a bit more depth later, but for now it's just the beginning primer. So next is lists. Lists are pretty easy. She was explaining lists like I can pull up a notepad. So the way the teacher was explaining in class was that so we have strings, right? We have strings, and these are just words, right? So if you have a string, it'll be like it'll hold this inside of it. Hello, right? So this is your string, and it has some 11 characters. You have 10 numeric character, not numeric, alphabetical characters in white space, and you can tell it's a string because of these little double quotes, right? And what she was saying was that lists are very similar to strings in that it's a bunch of objects. So in our string here, we have 11 characters. In our list, we can have the exact same thing. We can have H, and then we can have E, and we can have L, and so on and so forth. And what she was trying to explain was that strings are basically just lists of characters, because each of these character is just a single alphanumeric thing, ASCII character, right? It's just a single one. And then your string is a list of these characters. You have to have a bunch of characters. Well, you don't have to, but you normally would. A bunch of characters in a row, and that makes your string. And the same things with list. But instead of it being a list of characters, instead of it being a bunch of characters, you can have a bunch of objects. So lists can have strings in them. So you can have hello. You can also have single characters. You can have C. You can have one. You can have a bunch of stuff, right? You can have true, which is a Boolean value. So on and so forth. 0.01, that would be a what would it be? What would it be? I'm trying to remember. It wouldn't be an integer. It'd be a double, I think. No, doubles Java. I'm getting my Java mixed up. Yeah, but it would be a more complicated thing than int with decimal points. And the thing is, and we're gonna go into this a bit more later, but I guess it's next. So I guess we can just go ahead and talk about it. So after we talk about lists, we can talk about multi-dimensional and or nested data structures. They actually talked about 2D strings, and then they also talked about nested data structure, which are the same thing. So a nested data structure is we have this list, right? And inside of our list, we have objects. You know what you can put inside of your string? That's right, another string. So we can have one hello, whatever, password in there or something. So you can have as many nestings as you want. Now, you don't want to do this most of the time. Most of the time, this isn't a great idea because you're going to lose track of this and it becomes, to access this, so if we have this list and let's say it's called nested, nested words, whatever. It doesn't matter. It's called nested words. If you wanted to access this hello, right, you'd have to do nested underscore words, and then you'd have to do. So we have 1, 2, 3, 4, 5, 6. And see, it's really hard. This is one object in this string, right? So it'd be 0. Sorry. So this has 3, 4, 5. So 6 objects inside of it. 0, 1, 2, 3, 4, 5. So this would be 5. And then you'd have to put another one, and it would be, so inside of this nested string, we have 2 objects. It's this string and then this nested list, not nested string, nested list. We have these 2 objects. We have the string and we have another list. So we'd have 1. So we have 0, 1, and then inside this one we'd have 0. And if you didn't do this one, so if you did this, you wouldn't get this string. You'd get this list actually. This list object would be returned. But if you do this, then you'll get this string hello. So as you can see, keeping track of these can become really hard by human eyes once you start nesting more than a second time. After this nesting, it starts to become very difficult for human eyes to look at it and go, this is how many are there. But nested strings are really important for a lot of things, and especially in higher levels, this doesn't matter very much here, but in higher levels, your nested strings, especially 2-dimensional strings, are called matrices. And this is for computer people, but your graphics card likes matrices, and your screen is made of a matrix, and it does matrix multiplication, and that's really fast. It's a lot faster than what your CPU does, and that's how AI stuff works. But for now, I don't know that we might be using this. I mean, yeah, we had a few classes that we're probably going to use nested loops for something, but we are probably going to want to know about nested loops. So this is not very helpful as an explanation for nested loops. More better explanation for nested loops. So we can just say nested underscore words. We can just set it equal to nothing. And then we can make a new nested words list. I mean, it doesn't matter, but. Right. So then we can make a list and we can make it of lists, right? So let's say we have a bunch of people input random characters. We ask them, give us a random character. And what we could do is, and not random characters, not characters, sorry, numbers. People will go out and they want to figure out what does a person think is random? What does the human brain think is random, right? So they'll go in, ask someone, what's 5 random numbers, right? So they'll say 12, 56, 37, 49, and 91. Okay. So that's person 1. Then you have person 2, and that's another list. So they think it's 1, 1, 2, 3, 4, 5, right? Very boring. Not random. So this is one use case that you could use. May not necessarily use it for this, but you can use. And in these cases, honestly, for this particular thing, like if you're having people, honestly, you probably actually want to use a dictionary. So we can say, because this is nested loops, right? And they talk about 2-dimensional loops specifically. This is a 2-dimensional loop, right? But every data structure, right? So we have lists, lists, tuples, sets, and dictionaries can all be nested. So in this dictionary of people, right? So we'll have person 1 named Jessica, and they think that the most random number is 100. They're bad at creating random numbers, but that's okay. They're allowed to be bad at that. And if I can get my 16, I believe. Yeah, so we can go here. As we can see, yeah, okay, just making sure I'm doing it right. I don't want to be doing it wrong. But I'm I just don't want to teach you wrong, but I'd probably just do it and it'd probably be right, right? And then, so this is our key value pair. So we're going to go over this a bit more, but what you can do is, right, and when we're talking about nested data structure specifically, we're not going over dictionaries yet. You can make this a list. You can say 11, 25, 35, so on. Any data structure can be nested inside of any other data structure. You probably aren't going to need this. It's most likely you're only going to nest loops. We might nest data structures because that is one of our, I think it's 18 goes over this. No, that's modules. Let's see if this one. No, not that one either. 15? Yeah, one of these goes over nested data structures. This one does not. This is, oh, it goes over 2D lists, so it's close enough. Yeah, but you might need to use nested data structures, but all you really need to know about nested data structures, I mean, I can look it up just to be 100% sure, but I'm pretty sure you can nest any data structure inside of any other. Can you nest any data structure inside any other Python? You can nest, yeah, okay. Just making sure. So the reason you might want to be careful with this, right, is that different data structures work in different ways. So you might want to be careful that you don't confuse yourself, because remember, if I want to add something to a list, right? So I want to add something to a list, I need to do like dot append or something along those lines, dot append. But maybe if I want to add to like, I think it was a set, you might use dot add. And if you want to add something to a dictionary, you might do dictionary this equals that. So as you can see, we add and change these data structures in different ways. So what I want to caution is that you be careful, because lists are very easy. There's a reason that you normally want to nest lists, is because this is complicated and this is confusing, but you just keep doing this, right? You can nest it as many times as you want, and all you do is you add another 2 square brackets. It's pretty simple. But with these, it can become very complicated, exactly how you nest them, how you call, if I do this and then I go in here and I add, and then I make a two, I think this is a tuple or something, a set. I don't remember exactly which. We're gonna go over that later. If you just like keep doing that, right? You go in here and you do that. How do you access this value, right? How do you access this value? I don't know. So you will need to use nested data structures. You will need to use them, but whenever you use them, be careful that you know exactly how to access them. So be careful that, so if we have like a tuple or whatever inside here and we want to change it, then we're gonna want to do this, right? So we have 1, 2, 3. And so if we have this is whatever this would be. If you want to change it or edit it, then you're going to have to use its specific thing here, because now this is currently a tuple, right? This is a tuple. You're looking at, this is saying this. So you want to specifically use its type of changing or deleting or moving or whatever. And you can't just use the list, because it's not a list. It's inside of a list, but it's not a list. So you need to be really careful with that sort of thing. How are we looking on time? Okay, it hasn't started complaining just yet. Good. Right. So next, we talk about nested data structures. Let's talk about tuples, right? I think they were both in 15. Yes. Okay, so we're going to talk about tuples and sets. And this is just talking about multi-dimensional or nested loops. Yeah. So this is talking about nested loops, I believe. No, was it? I don't remember. Here it's going over 2D lists. So just talking about 2D lists. So you have to use this, access all this. I think 2D lists are pretty simple. I don't think there's too complicated. I think we're pretty, like, if you go and open Excel, right? We go over here, we go Google Sheets, it's Excel. If I open a blank sheet, this is a 2D, this is a 2D. This is basically a 2D object, right? You have dimension 1, dimension 2. It's pretty simple. We understand that, right? It's just flat. It's just flat space. But once you get to 3-dimensional and on, and you keep nesting, it becomes very complicated. I really doubt she'll go over a single nesting. But if she does, just be careful that you're treating it properly and understanding how to actually access it. Whatever data structure it is that you're accessing. And of course, when you want to iterate over it, yeah, you're gonna need to use multiple loops, else you're not going to actually get the values, you're gonna get the list. So if you only use one for loop here, then you wouldn't be getting Joe, you'd be getting this list right here. So just gotta be careful of this sort of thing, right? Yeah, so here it shows if you only access the thing. So this is a list. This is not a string. You're not accessing your attraction. Sorry. Well, this is length. This isn't whatever. This, I mean this. Yeah. So now we're gonna look at tuples. So tuples, if I remember correctly, tuples are the ones you can't change. Yes. So there's a few different things that these data structures can be. They can be mutable, immutable. They can be ordered or not. Or I don't know if it's disordered or lacking order. I'm saying ordered, not sure. If ordered or not ordered, and then you can have indexable. That's what it is. Indexable, non-indexable. Yeah. But no, actually, that's different. That's different. Sorry. That's actually a different thing. Sorry. Oh. So the reason I say that is that so when you have sets, a set is when you put stuff into it, when you add stuff to a set, right? You add 1 and you add 2 and you add 3. When you pull stuff out, it could be in any order, right? You come out 2, 3, 1. You could come out 3, 2, 1. The only thing that you know about a set is that when you call stuff from it, when you pull stuff out of it, it'll always not repeat, right? That's the only thing you know about it. You don't know the order, and it doesn't have an index. But dictionaries, they are ordered. When you put something into it, when you add to a dictionary, you just set it, you do this equals something. It will be in an order. If you add A with 1, and then you add B and 2, it will be in this order. When you if you just pull from it, you say print dictionary, it will print A1 and B2 every time. That is an order, but it's not indexed. What I mean by that is if you say dictionary, you know how with lists, the first object, second object is 0, 1, 2, 3, 4, so on. With dictionaries, if you put in 1 here, we don't have a 1. There is no key that says 1. We're not getting a dictionary. I keep talking about a dictionary, but I'm just trying to explain to you how indexable, non-indexable. This is not indexed. It's not in 0 to infinity list. You can't do that. That's not how dictionaries work. Dictionaries work with keys and values. But tuples act exactly like lists, but you can't change them without just honestly, you basically can change tuples just because you can just set a tuple equal to itself. So you can say, tuple thing, and just say tuple. Tuple equals, it's capitalized. Then you can say, you can add something to the list. So you can say add A. I don't think this is how you actually add to a tuple, but you could add the tuple, or you can set something equal to a tuple plus something. You're not actually adding to this tuple. You're setting this equal to this tuple plus this, right? And then so you can't technically change it, but in reality you can. And they might ask us to use tuples, but basically all you need to know about tuples is that it uses parentheses. It uses parentheses instead of square brackets, and that other than that, with the exception of not being able to change these values, it's basically just a list. It's basically just a list, except it uses parentheses, and you can't change things. You can, but you can't. So I think the reason tuples exist, right? The reason tuples exist is because they're faster. They require less oomph out of your machine. They'll run faster. If you only use tuples, they'll be way faster. Or rather, if you only use tuples in the way they're supposed to be used, which is putting something in a tuple and then just calling from it. That's way faster than a list. But it basically just acts like a list for our, right? For you and me on this exam, it's basically just a list, but the way you change the stuff inside of it is a little bit different. It's a little more complicated, right? They're in order, yeah. And you can put data types in them. You can put data types in every kind of every kind of thing. Oh, and I almost forgot, right? So we have iterable. So iterable can loop over the elements in a list. Yeah, so I'm pretty sure I think all of them are iterable. I don't think any of the ones we've learned yet are non-iterable. I think sets are pretty close to being non-iterable, but they're not quite. They are iterable. I'm pretty sure all the ones we're using are iterable, right? So we have these are 4 like axes which they can be on. And yeah. I think this is it. I'm not sure. But yeah. Anyway, so I'm gonna go ahead and we're gonna just go ahead and say list, and we have this. And then we have tuple. We're looking on it right now. Like this. Yeah. So list tuple. Well, when you actually access the tuple, it's just gonna do this, and it's gonna equal to tuple equals this. In 10 minutes. That's okay. We'll end in 10 minutes and restart it. So that's our tuple. So it's basically just a string. Not actually just a string, but it's pretty close to just being a string. It's a little bit more complicated, right? It's not too complicated. It's not hard, right? I don't think we need to work for it any longer. Length. So let me just talk about this real quick. Basically, what the length function is, you type out len and you put an object in there, specifically a data structure, and it tells you how long it is, or rather, it tells you how many objects are in it. So in a two-dimensional list, if you have a two-dimensional list, right? So if you have a two-dimensional list right here. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 objects all together, and it is an object itself, right? But if you do len nested words, this one specifically, it will give you 2. It will give you a length of 2 because at this level, it's just 2 lists. But if you did len nested words 0, right? You did len of nested underscore words 0. This would give you the length of this object. So you'd get 5, right? So, well, once again, just being careful with that nested loops. They can be a bit tricky. Normally when we put our data structures into ling to get our length of our objects, we usually just put it in like this. But what you need to understand is that this is just accessing this. It's just looking at this. It's not looking underneath. It's just looking at this top level. Now, this top level in a normal list, one-dimensional list, it's going to give you everything. But if you're using 2 or 3 or 4 and so on dimensions, it's only going to give you how many objects are in here. It's not going to give you how many objects are inside of your objects. So yeah, a little bit more complicated. We're talking about nested loops, but not super complicated. I think it's pretty doable. I think y'all can manage it. Indexing, yeah. So it talks about this. Yeah, ending starts at 0. And that's why I said that dictionaries that are not indexable or aren't indexed, whichever. Yeah, all of them are indexed except for dictionaries and sets. Sets are not ordered and non-indexable. If something's indexable, it has to be ordered, but if something's ordered, it doesn't have to be indexed. But what I mean by that is that if my list is in order of 1, 2, 3, 4, 5, right? It's indexable if I can say list 0 or like a position 0. It will give me 1. If I can't do that, then it's not indexable. But if it isn't ordered, right? If I plug all these in and then I call for 1, it gives me 3. That's not in order, right? But if it's not in order, it can't be indexable, because if it's indexable, then I could just call 0. I don't need to, put for I in list. I don't need to do that and get it out random. Like just say 0, 1, position 0, position 1, position 2, position 3, position 4. Then it's ordered because it's in an order. Not that I don't think that matters too much, but just something to note is that if something is indexable, it has to be ordered. Something can be ordered and not be indexable. Just something to note. Dictionaries specifically are the only one, I think. Yeah, dictionaries are the only one that are ordered but not indexed. All the rest of them are either ordered and indexed or neither, which is sad. Slicing. Oh yeah. So probably want to talk about slicing real quick. How much more time do I have? 5 minutes. We're chilling. So slicing is just grabbing a part of a list. It's not super complicated, but what's the thing? Yeah, it's just like, so if I have a list which is equal to 1, 2, 3, 4, 5, and the position of these are 0, 1, 2, 3, 4, 5, or 1, 0, 1, 2, 3, 4, right? So 0 is 1, 1 is 2, 3 is 4, and so on, right? So this is the index, and these are the objects inside the list. And if I splice it, or slice it, not splice, sorry. Then from where I start, so if I do start in, so if I do list, and I do here this, and so if you don't do anything, it'll just give you the whole list. Yeah. So I believe, I don't remember exactly how slicing works. We can just go ahead and check. So let's go to our untitled doc here, and we're gonna do this just so we don't lose it. Not that it really matters, but why not? So we can go ahead and check how slicing works. I don't remember exactly how it works off the top of my head. Unfortunately, I'm not Giga Brain, remember everything. That would be nice. But yeah, so we have list. I can't say list. List is a special class. You can't call your variables list. So I'll call it project. Project equals 1, 2, 3, 4, 5, right? And if we do print project, and we do 1, 4, I believe it should go 2 to 5 unless one of them is like leaves out something on the end, which I don't know. Why we're checking. Oh, I need to name it. Oh, bother. Documents, Python scripts. What is this? Midterm exam test. This. So yeah, so it starts here, and okay, so this is inclusive, and this is exclusive. So okay, I'm gonna explain what I mean by this. So this is in, and this is X. So what this means is that if I if I put position 1 here, position 1, which is 2, then 2 will show up. 2 and everything to the right of it. This is start and end. Yeah. So you're deciding to start and end, and the start is inclusive. So when you start at position 1, it includes position 1. But if you end at position 4, it excludes position 4. So what you can think of this as is that we can do, yeah. So we can color code these. Let me make this bigger. There we go. That's better. It's been having it tiny this whole time. I just don't notice it. Yeah. So this is stop. So stop. This might be confusing. I hope this isn't confusing. If I'm confusing you, I'm very sorry. But what I mean by this, stop telling me to go back. Damn word trying to tell me how to do things. So this by having this red, we can say this is not included. And then, oh, actually, this works perfectly. This is I accidentally made it really good. Okay, so let me start again. This is where it starts. This is where our slice starts. It starts at this number. So let's say this number is 2. So we start here and we include it. So green means go and include. It's doing double duty. It's working. And then red means stop and exclude. So if we stop at 3, we're gonna have a single character in here. Then it will end here, sorry. End, this is our end, and it will exclude. So we'll only get 3. So if we do 2, 3, 2, 3, we'll only get this one because it includes this but excludes this. I think we're about to lose our meeting. Yeah. So I'll go ahead and end this one and pause, stop share, and I'll pick up with the next one. Stop